there's a fairly detailed risk assessment approach that we go through on every project that we do for determining how much treatment we need. And the way it manifests itself might be, like I say, if we're doing rainwater harvesting for subsurface, we might do no treatment at all as long as you've got a mulch barrier. If you and that can be, and it can be demonstrated that that's appropriate through this risk assessment public health methodology that's been established by people like the World Health Organization, using some fairly detailed risk and exposure calculations to support what we do. And beyond that, it's we might say, okay, well, if taking it to the other extreme, if we've got blackwater treatment in the basement of a building and we're wanting to reuse that for cooling tower use, well, then we'll have screening, biological treatment, ultrafiltration through membranes, maybe some UV disinfection, perhaps reverse osmosis, chlorine disinfection, because you've got multiple barriers of disinfection, which gives you a higher quality pathogen reduction capability, and therefore you know that it's safe. Well, that comes at a cost, so it's about determining where you should sit within that range, and it's really I think it's a very valuable step in establishing this, because then you can agree with the public health officials in the state, the county, the city, whomever you're dealing with, what that level of a treatment is, and you're talking their language, and you're more likely to get approval because they understand the rationale that you've used, rather than me walking in saying, I think it should have this level of treatment. Bill might walk in and Doug might walk in and have a different opinion as to what level of treatment it is. Well, here's a way that we can all agree because it's robust, it's well calculated. It takes a lot to get your mind around, but it's no different than too many other codes, the question was what the website for that. The methodology that we use is the National Recycled Water Guidelines. It comes from the National Water Initiative in Australia. I think if you just Google pages within Australia, National Recycled Water Guidelines, you'll find the link. It's about a 400-page document. It's quite daunting, and it won't give you too many tables saying, you need this level of E. coli in your treated water. What it does is establish this methodology for working this out. So I don't want to overcomplicate it, but what we find is that once, like anything, once you get your mind around this, you understand the way the calculation's done, you do the calculation for one application, you've done it for that application. And so, one commercial building is similar to the next commercial building, so you don't have to do it every time.
And they're guidelines, not regulations.
These are guidelines, yeah. Now, the regulations, of course, differ from state to state in Australia, as they do here in the US, and differ sometimes from municipality to municipality. We have the same hair-pulling exercise that unfortunately you have here, but I think you've got it more so because you've got so many more states than we do. But basically it's similar sort of principle to the US EPA, where they provide this sort of guidance document that the states can choose to pick up on if they want. Yeah, but it's a useful tool, and so then the question is about how to implement that in a way that makes it safe for the end user. And so, talking about some of the regulations in New South Wales, the major state of, or one of the most populated states in Australia, they've established a licensing scheme for people putting in these decentralised systems, where you have to establish your technical capability, your organisational capability, and the financial viability of both your organisation and the scheme, this recycled water scheme, to get its approval. And it sets the bar pretty high, but I think it's a good thing in that it it kind of keeps the cowboys out, if you like, which is necessary, because we've seen a few schemes go in that fall over because they haven't been properly executed, and so it also requires a certain level of rigour before a scheme gets up. So what we've all seen, I'm sure, with some really great technologies where they're put in, but there's been little thought to the ongoing operation and maintenance of them. And so this takes that into account. So that's what we've seen certainly in Australia. Yeah. And so, it goes through a whole lot. It took us, we were the first company in Australia to get this license. So we're effectively like a private utility now. And it took us about 14 months to get through all this. But once we've got it, it's easier to get it for subsequent sites. And so here are some examples of what we're doing here. This is a typical commercial building. In this case, we're talking about blackwater recycling. So we're taking wastewater from all of the fixtures. Sorry, Doug. And collecting it in a point. In this example, it's a sewered area. So the waste would go to the sewer if the plant wasn't operating or if it's down for maintenance. And you're picking it up, putting it into, we have screening, biological treatment, ultrafiltration, UV disinfection, chlorine, residual, and in some cases nutrient removal. There are some good examples of this that's happened in the US. There's quite a few plants that are going in Manhattan, some Battery Park. There's some blackwater recycling plants that are going in basements of buildings and being reused. The challenge is to make it affordable. Means that you really got to design it from the ground up. What we've seen over the years is that municipal scale schemes have been tried to be scaled down for this application. When you've got the sewer as a backup, you can remove a whole lot of redundancy. You can take the system down for maintenance, which you don't have that luxury in a municipal sewage treatment plant. So these are the sorts of design philosophies that we introduce into what we do, just to cut down on the cost. And it's about being practical, really. There's a project in Sydney downtown area. It's a very upmarket building. We're taking water from the sewer that walks right by this building, because what we're seeing this trend towards is that the buildings are becoming so efficient with fixtures that you can only generate enough wastewater from the building itself, especially commercial building where there's not much in the way of showering, no residents, where the toilet flush will just generate enough water for reusing for the toilet flush, but only a quarter of the building use is toilet flushing, the other 3/4 is cooling towers. And so we're actually extracting from the sewer to be able to use and have enough water for the cooling towers. And this is one case where that's necessary. If in other cases where there's a high proportion of residential apartments in there, you can generate enough from the base building because of the showering load. So you can generally recycle as much as possible from within the building itself. I'll flick through some of these. Greywater, separating the drainage from the blackwater. A bit less treatment involved, but similarly into treated water storage and back in for things like toilet flushing, clothes washing, and irrigation. So that's the type of projects that we're typically doing.
Colin, in the blackwater recycling, is the remainder of the waste being discharged to the municipal sewer?
Yes, it is. Yeah, sometimes.
I guess there's never been a problem when individual businesses, when these are the few, it seems like we can deal with it. But imagine, I guess what I'm wondering is, anybody really studied the impact of what if every building downtown had that same process? What happens to that municipal system? So basically what happens is the customers are taking the best part of their wastewater stream and then trying to give the remains to the agency with very little water to carry it. And I just heard this through the grapevine that in Brisbane they're having a hell of a hard time getting waste through the sewers, that they're actually going out and using tens of millions of gallons trying to flush sewers because of the residue buildup. And so I still feel like what I'm very interested in is seeing what happens when somebody takes these impacts and scales them up to entire cities or entire communities, and what the impacts are, because they want to use and I understand this, you want to take the good part of the water and then leave the rest of it to the municipality, but I don't know how long you can do that.